welcome. 9 new cases of critical chain implementation. Another one here, which is there's people who also develop very specialized machinery for making bottle tops and all sorts of other stuff on food and drink assembly lines. We did a short diagnostic and proposed an action plan, and they went and did all this on their own without us. So this is what we said when we looked at what they were doing. We just looked at their research and development department, and we said, "What you've got too many projects in your pipe." Okay, this is why I put it in big and black here, Little's Law. Please, it's easy for you to do. Check what situation is in your research and development organization by applying Little's Law. It's the average duration equals the number of projects in progress divided by the number of projects completed per year. If I have 20 projects ongoing in my research and development organization and I only finish 2 a year, well, then it's taking me 10 years at least per project on average, right? And yet in that organization, when I go and ask them before they do that calculation, how long it takes, they say, 2-3 years sort of thing, right? Do that calculation, please, because most of our prospects and clients don't realize that their performance is a lot worse than what they think. Just do that simple Little's Law calculation. Number of projects divided by number of projects per year, and that will give you the average duration of your projects. We're regularly seeing companies with over 10, sometimes over 30 years, 30 years of average, which, you're not going to get any new exciting stuff to the market if it takes you 30 years to get it as a time to market. Anyway, this is one of the things that we said, and they applied critical chain, and they're cleaning it up as we speak, and they had to reduce the level of work in progress. They got rid of some of the projects and froze others, planned them the critical chain way, and on the priority projects they focused on to get them out the door very quickly. A classic, which worked very well. Yet another one here. This is again in aeronautics, but it's aeronautical components, various kinds of valves for aircraft. They had poor delivery performance. This is the company Circor, if you CIRCOR. If you look at our YouTube channel, you'll see lots of videos by the client talking about this, by the way. And so we implemented critical chain on pilot projects. Once that was done on the entire portfolio, we used mascots. Again, look at the videos to understand what that means. Mascots that enable you to visualize in the organization where the critical tasks are. That's always very popular. We do that with nearly all our clients. The fever chart was used obviously as the core thing in the weekly portfolio management meetings. They had the qualification laboratory as the bottleneck initially. That was it was obviously not the right place for it to be. Qualification laboratory is the sort of thing that has, a saline environment to see if the product rusts and whatever. It's where you torture the product a little bit to make sure that it's going to be okay. So it's not a very high tech part of the operation, right? But it can take time. It had unfortunately become the bottleneck. We got rid of that by having some simple lean ideas, checklists and stuff to make sure that it didn't get in the way. And so that was eliminated as a bottleneck, because obviously not the right place for a constraint to be, so they managed to get a lot more out of the system than they used to. The results here is that they used to take 3 or 4 years to develop a new product, and they went down to 18 months, and this is a 2024 case. They're getting better and better. They're continuing to speed up. That's already a 50% reduction. The qualification phase, right, which used to be the bottleneck, which was initially taking 4 or 5 months, was reduced to only 2 months. So more than 50% reduction on that, just on that one step. They did stuff also, so I don't want you to think, critical chain was the only thing that was used for these results. That speed up from 3-4 years to 18 months came about also because, for instance, they reintegrated, they brought back in-house some prototyping, which enabled them to save several months on the critical chain, right? So sometimes it's not just the ideas of critical chain that bring these results. There's some other things going on, okay? Please don't think I'm saying critical chain is the answer. What is your question? Critical chain gives you an impetus and puts you shooting along in the right direction, but there are other ideas that we mix in to get all these results. Great visibility. And there's another nice example of a fever chart, a portfolio fever chart that you've got here. This is yet another case. In fact, these are very sophisticated machines that are weaving machines that weave carbon fibers to make 3-dimensional carbon parts for aircraft engines, right? So this is very, very high-tech stuff. And the machines that make these parts are very interesting beasts. Okay, this is an international company with nearly 100,000 people, over 100 factories. This was installing and moving these machines between the United States, Mexico, and France, and making sure that it all went as quickly as possible, because this was very critical. These engines were in great demand and they're overdue and so forth. So there was a lot of pressure to go faster. They decided, therefore, they wanted to ensure that the machines were installed and ramp up very quickly. Absolute classic project planning with the client and the different stakeholders, because many people involved. Identify the critical chain, and when they identified it, they saw that if they didn't change things, they were going to end up late. So they then optimized it or improved it. Right, the critical chain way of doing a project fast is not to scream at people. It's to say you calculate objectively the durations. And if the end date is unacceptable for whatever reason, you stop and think, how can I do it better? If I do these two tasks at once, if I add more people, can I go faster? And what can I do with my external supplier, external vendor to go faster and whatever, right? And so that was required to be able to accelerate and to get up to the speed that they were expecting. These are the kind of results. So yet another example of those kind of real world fever charts that you can get, right? It started off well down here, but then it suddenly had a problem and went shooting out here. This one had a completely different experience. Fine at the beginning and got a problem near the finishing line. They did finish on time. All of these machines were all individually installed on time, even though they had lots of problems. Yet, they feel that they managed it with very little stress, given the importance of the project, because of the visibility it had. They could react when necessary. They finished on time, so they were all very happy. If you want to hear the client describing his journey, if you look at our Marris Consulting website on the conferences, the Albany Engineering Composites story is there, presented by Phil McGrail of Albany Engineering Composites, and it's a great presentation, by the way, so I highly recommend it.